All right, if you would go ahead as we get started, we're going to start with another speed test today. So if you would, have everything aside except for your speed drill booklet. Open up to page 2, which technically is the first page of speed drills. And we've already done speed test 1, we've done speed test 2. We're going to do speed test 3 today. Notice it's a multiplication box. Are all of us familiar with how to work one of these? Does anyone need explanation? Because we're going to have several of these throughout the year. Does anyone say, Mr. Dasky, I'm not quite sure what I'm about to do. Can you show how to work a multiplication box? Does anyone need help? Okay, so basically how it works, you'll notice there's different numbers and columns and things like that. So maybe there's a 3, a 2, and a 7, and maybe there's a 5 and a 4. What you're going to do is you're going to say, well, in this box, it's 3 times 5, which is, Kirsten, 15. This is going to be 5 times 2. And this, of course, would be 5 times 7. Uh-oh. 35. All right. And then here, this isn't going to be 5 times 3. This is going to be 4 times 3. So 12. Here we'll have 8. And then here 28. Does that make sense now how we're going to work it? All right. Any other questions on multiplication box? Is that everybody good to go? All right, you'll have 2.5 minutes to complete the multiplication box. You can go across rows, you can go down columns. You do however is easiest and best for you. The goal is to get as many correct answers as you can before the alarm goes off. You ready? You may begin. Stop. All right, put your pencil off your desks. Pencils off your desks. Have out just a pen, and you know the routine. Pass it to the person behind you, person in the back. Walk yours up to the front. And in pen, sign your name at the bottom of the page as the grader. Again, pencils should be off your desks. Pencils off your desks. What's the problem? You got it? All right, yes, you should have Ben's, and Michael, you should have Kirsten's. Good? All right, in pen, sign name at the bottom of the page as the grader. Pencil off your desk there, Sam, Paige, Griffin, pencils off your desks. And just set them to the side of your desk. No, off the desk, but to the side, beside you. on the floor or in your pocket. That works. Off your desk. There you go. All right. Here's what we're going to do. I am going to read each answer only once. So listen carefully as I go across each row. Do not try to write the correct answers in. Simply put a slash through the number if it's wrong. And then at the end of each row, I'm going to have you count up how many wrong just in that row. All right? So here we go across the row that begins with the 8. Your answers are 72, 16, 40, 88, 24, 56, 32, 96, 64, 48. At the end of the row, put a minus number. Hopefully it's -0 that you write. But if it's -1, -2, whatever, however many slashes you had to put that minus number at the end. Yes?
What if they didn't finish?
If it's empty, it's wrong. Right? So if it has a wrong number or it's empty, it's wrong. Right? Just like on anything else. Right? The row that begins with the 6. Listen carefully. Again, just put a slash if it is incorrect. 54, 12, 30, 66, 18, 42, 24, 72, 48, 36. Put the total number of slashes at the end. Again, hopefully -0, but whatever that number is, write that at the end of the row. For the row beginning with a 9, 81, 18, 45, 99, 27, 63, 36, 108, 72, 54. Again, put the total number of slashes at the end of the row. For the next one, the row beginning with a 7, your answers are 63, 14, 35, 77, 21, 49, 28, 84, 56, 42. The total number wrong at the end of that row. And the last row, the one that begins with the 12, your answers are 108, 24, 60, 132, 36, 84, 48, 144, 96, 72. Put the total number of slashes at the end of that row. Now, hold on. What I need you to do now is figure the total number of slashes. Multiply that by 2 points each and figure the score. So these are 2 points each, 2 points per slash. Okay? So figure how many slashes were there. So you've got the numbers off to the side. So maybe you've got -0, -1, -3, -2, -1. Well, that'd be 7 total slashes, right? Times 2 is 14 points. 100 minus 14, that person would have an 86%. Okay? So figure the total number of slashes times 2, subtract from 100. Put the score in the score blank if you would, and then also make sure you go to that first page inside the front cover. And next to where it says Speed Drill 3, put that score. Right next to where it says Speed Drill 3, put that score. All right, so the score goes 2 places. Once you got that score on there, return to the owner by passing it forward. If you're at the front of the row, take it to the back of the row. So for those who are at the front, take it to the back. Good toss, good toss. If you're having trouble, I will go through and regrade everything anyway, so if it's not adding up well for you, just hand it back and I will take care of grading. All right, I am curious if there were any hundreds. I mean, there were 50 answers you'd have to have right. How many got all 50? You got 100%. Wow. Okay, how many got an A of some kind? You missed 5 or fewer, which is still really good. How about B's? You missed 10 or fewer, which is pretty respectable still. How many of us need to work on our multiplication tables? How many of us are glad this isn't actually a quiz grade? It's only a 14th of a quiz grade. Okay, there's some of you there, yeah. Okay, so continue working, right? If this was not really sharp for you, keep working on your multiplication tables. At home, over the weekend, get online, get on Google, Google multiplication games, and play games. Make it fun for yourself. But let's get multiplication figured out. Pass those forward if you would, please, now. Pass those forward, if you would please. Putting yours on top. So pass them forward down the row. Putting yours on top. Take out your textbooks, turn to page 17. Page 17 in your textbooks. Question, Michael? I am. Yep. All right. Page 17 in your textbooks. Quickly. You did the homework section, numbers 1 through 20. I think this was the most straightforward homework assignment there we go. I thought I was missing one. Most straightforward homework assignment we've had in a while. Just 1 through 20 was all on one page. Should have made it pretty easy for you. So no handouts or anything like that for a change. Good. All on the paper. All right, good. Good. Thank you, ma'am. Thanks, sir. I see it. Excellent. Good. Yes. Okay. Good and good. All right, let's take a look at our answers here. And number 1 through number 4, they were asking for you to write out the common factors of these numbers. So what you would have needed to do is figure out, well, what are the factors of 18? Well, hopefully you figured out they were 1, 2, 3, 6, 9, and 18. Then you had to figure out, what are the factors of 21? Well, 1, 3, 7, and 21. That left us with what common factors? Jalen?
This is a question. What if we didn't write the 1?
Yeah, I'm not going to worry about it too much. So what did you have for your common factors?
I had 2, 3, and 6.
And for number 1? Well, your factors of 21, right? We say that's 1 times 21. Does 2 go in?
4.
Okay, let's look at number 1. All right, number 1 from the homework. And what were the common factors for number 1 in the homework? Oh, you were thinking, I'm sorry, you didn't say you did number 4. You were thinking 24 instead of 21. I got you now. All right, let me go to Paige. Her hand was up a moment ago. What were the common factors?
1 and 3.
1 and 3, very good. For number 2, what were the common factors? Elaine?
1 and 11.
1 and 11. Number 3, what were the common factors? Corey?
1, 2, and 4.
1, 2, and 4. How about number 4, Sam?
1.
Well, there's more factors than just 1 common for 30 and 45. Let's think about 30 and 45 real quick here, Sam. Let's take just 30, right? 1 times 30, right?
Yeah.
Does 2 go in? Times, take 30 minutes on a clock, cut it in half, 15, right? Does 3 go in?
Yeah.
Times?
7.
3 times 7 is 30.
No. 10.
3 times 10, there we go. Does 4 go in? No. Does 5 go in?
Yeah.
5 times? Think of a clock. What number on a clock is 30? It's down at the bottom. It's the 6, right? 5 times 6, because counting by 5 is on the clock. So 5 times 6. Now 5 times 7. So your factors are 1, 2, 3, 5, 6, 10, 15, 30. Then we have to do the 45. 1 times 45. Does 2 go in, class?
No.
No. Does 3 go in?
No.
Yeah, 45 minutes on a clock is 3 sections of 15. Does 4 go in, class?
No.
No. Does 5 go in?
Yeah.
Times
9.
9. 6 go in?
No.
No. 7. We don't have a rule for 8. 9's already on there. So my factors are 1, 3, 5, 9, 15, and 45. So my common factors, we should have had, of course, 1. If you didn't write it, no problem. 3, right? 5, and 15 are your common factors. So you should have had 1, 3, 5, and 15 for number 4. Questions on finding common factors. Does that make a little bit more sense? All right, questions on that? For numbers 5 through 12, you're identifying the numbers either prime, composite, or neither. What'd you get for number 5? The number was 18. Bryson? Composite. How about for number 6, the number 73, Luciana?
Neither.
Well, the only numbers that are neither prime nor composite are 0 and 1. So 73 either has to be prime or composite, and 73 is at least 1 times 73, right? Now, if there's nothing else, then it's prime. Does 2 go in? It's not even. Does 3 go in? Some of the digits is 10. 3 can't go into that. 4, you could try to divide it. By the way, if 2 doesn't work, 4 can't either, right? 4 is an even number. It has to be even with the 2 for a 4 to work. So we know 4 doesn't work. Doesn't end in 5 or 0. 2 and 3 don't work. 7, we could try, but 7 times 10 would be 7D, not 73. 8 won't work, so that's even. 9 doesn't work. Nope, it's just 1 in 73. So we would say that that number is prime. There we go. How about 51, number 7? Michael? Ooh, it is not. 3 can go in. Look at the sum of the digits. 5 plus 1 is 6, so that is composite. How about number 8, 44? Kirsten?
Composite.
Composite. How about 58, number 9? Ben?
Composite.
Composite. It's an even number. How about 2? Griffin?
Prime.
Prime. It's the only even prime. Remember, 23, class? Prime. And 1, class?
Neither.
Neither. You were writing the factors using the division of primes. Number 14, the first prime. Well, let's real quick recap, class. What are our first 8 prime numbers? Say them with me. 2, 3, 5, 7, 11, 13, 17, 19. Again? 2, 3, 5, 7, 11, 13, 17, 19. Which of these should we divide the 14 by, Griffin?
2.
2 to get?
7.
And that's prime, so we're done. Our prime factorization of 14 is?
2 times 7.
2 times 7. What do we do for 70? What's the first prime number we should technically divide by? Jalen? 2. And what do we get when we cut 70 in half?
I got 32.
Ooh, not 32, class?
35.
35. Can 2 go into 35, class?
No.
3?
No.
5?
Yes.
Yes, 5 times 7. Hey, that's prime, so my prime factorization of 70 should have been 2 times 5 times 7. What did you get for your prime factors of 150, Sam?
I have a question.
Question. Yep.
Could you also done 7 divided by?
Yes, you could have started with the 7, gotten a 10, and then recognized the 2, and then getting the 5 that way. You could have. It's same 3 factors, right?
No, like I did 2, then like 70, then I did 7 divided by 35 and got.
Oh, okay. You got the 7. You divided 70 by 2. You used the 7 instead of the 5 to get a 5. Yeah, same 3 numbers. Same 2 numbers. The only thing is, the best way to write it, instead of 2 times 7 times 5, the best thing is to list them numerically. 2 times 5 times 7. So if you always use the smallest one first, it keeps them in that order, but it doesn't technically matter now. Good question. What did you get for number 15, Sam?
5.
Well, 5 is one of the prime factors that we could use. I mean, we could do that. 5 would go into 15. 3, and 5 goes into 0 times. We could break the 30 with what number, class?
5.
5 again to get?
6.
6 could break down with a
3.
3 to get
3.
2, or a 2 to get 3, whichever, right? Careful, not 3 times 2, that'd be 9. So 2 times 3 times 5 times 5 would be our prime factors there of 150. Number 16, what did you get? Corey?
2 times 3 times 3.
Ooh, for 63, number 16? Help Elaine?
3 times 3 times 7.
3 times 3 times 7. How about 99, number 17? Let's go back to Corey for redemption.
3 times 3 times 11.
3 times 3 times 11. Number 18. What did we get for that one, Michael? 140.
2 times 2 times 5 times 7.
Excellent job. Number 19. The 6 factors of 18 should have been 1, 2, 3, 6, 9, and 18. And number 20. Which of those 3 numbers, first, second, or third, is divisible by 3, class?
2,000.
The second one, 2,463, is correct. Questions on the homework? Turn over to page 20, if you would, please. Page 20. On page 20, I want you very quickly to do numbers 23 through 29. When you finish, go back and read over pages 14 and 15, those fast facts. Right now, worry about doing those review questions. Think through carefully this group. a little longer to be finishing up. Most of us are about done. Let's take a look at these together. Number 23, it's a true or false, but notice it says if it's false, replace the underlined words with the words that would make the statement true. So for number 23, it says the number 122 is divisible by 3. First of all, is that true or false, Luciana?
False.
False. 1 plus 2 plus 2 is not going to add up to something divisible by 3. What could you divide 122 by? There's a few answers you could put.
2.
Is divisible by 2. That's hopefully what we put in the blank. If you put 1, I mean, you're not wrong. If you put 122, yeah, duh. If you put 61, okay, that's a little more creative. But 2 is kind of what I was looking for there. Number 24, the number 36 is a prime number. What say you, Kirsten?
False.
False. It is a
Composite.
emphasis on the second syllable. Composite number. There we go. Number 25, 1 and 2 are neither prime nor composite. Ben?
True.
Well, they're kind of half true, right? 1 is neither prime nor composite, but 2 class is prime. What's the other non-prime, non-composite number, Ben? It's not 1 and 2, but 1 and 0. There we go. So 0 and 1 should have been in the blank. Number 26, the number 1,287 is divisible by 3 and 9. What say you, Paige?
True.
It is true. It's divisible by both of them. The sum of the digits, 18, is divisible by both 3 and 9, so is 1,287. Number 27, 2 is the only even number that's prime. Griffin?
True.
Also true. Number 28, 1, 2, 4, 5, 10, and 20 are all the factors of 20. Is that true, Sam?
True.
Yes, it is. And number 29, the common factors of 6 and 30 are 1, 2, and 6. Jalen?
1, 2, 3, and 6.
Good. It's almost true. 1, 2, 3, and 6. They left out the 3, which is another common factor. How many got all those right? You figured out all of those correctly. Good, several of you. Any questions on the review questions? Any questions? Flip over to page 14. Now, I told you if you finished early, look over this section. Of course, last night for homework, I told you I wanted you to look over the fast fact on page 14 and the fast fact on 15, which we'll get to in a moment. It mentions this thing, prime to each other. I want you to mark the first sentence inside that blue shaded box. 2 numbers that share only the common factor of 1 are said to be prime to each other or relatively prime. Mark that sentence. Either highlight it, underline it, star it. Know that fact. Prime to each other. They got nothing in common except for, of course, 1. For instance, 4 and 5. Well, the factors of 4 are 1 and 4, 2 and 2. The factors of 5 are 1 and 5. What factors do they have in common, class? Only the 1, nothing else. These are prime to each other. Now, 4 is not a prime number. 5 is, but 4 isn't. But they are prime to each other. How about this? What if we went with the numbers 18 and 63? Are they prime to each other? Do they have anything in common besides 1? What do you think, Jalen?
3.
They have a 3 in common. So, Jalen, are they prime to each other?
No.
No, they are not prime to each other because they have a common factor of 3. Does that make sense? These are prime to each other because they don't have any other common factors. What about the numbers 10 and 21? Would these 2 numbers be prime to each other? What do you think, Ben?
No.
What do they have in common? 10 and 21. We could factor it. 1 times 10, 2 times 5, 1 times 21, 3 times 7. But is there anything common besides 1? Besides 1? No. So are they prime to each other? Yes, that's what prime to each other means, Ben. If all they have is the 1, that means they're prime to each other. Does that make sense? So these have a 3 in common, right? This would be 3 times 6, this would be 3 times 21. They both have a 3. They are not prime to each other because they share something. They have something in common. So prime to each other, okay, let's put it this way. Have you ever, I know you're young, you're only in 7th grade, right? But maybe you've seen older siblings or something like that, and you see a couple people and you're like, I would never have put those two people together. I don't know why. Why are they together? They have nothing in common. You ever seen something? You know what I'm talking about? Okay, I know you're only in 7th grade, but I feel like, okay, if they have nothing in common, they're prime to each other. If they do have something in common, they're not prime. Does that make sense? How about this pair of numbers? All of you kind of think through this. 6 and 8. Prime to each other, or do they have something in common? What do you think? Griffin?
They have something in common.
They do have something in common. What do they have in common?
2.
A 2, right? So they are not prime to each other. They do have something in common. Does that make sense? The prime to each other thing, that fast fact, we understand it now? All right, I want to look at the other fast fact at the top of page 15. And this is an alternative to the division of primes. And personally, I find this useful, especially with big numbers. Something called a factoring tree. Look at the way that they factored the number 36. Looking up this way. Paying attention, page. If I use division of primes, head off hand, Jalen, I would start by dividing by 2, and I'd get 18. And then I divide by 2, and I get 9. And I divide by 3, and I get 3. Right? So my factors of 36 are 2 times 2 times 3 times 3. The problem is, class, we're starting with 2 times 18. We didn't memorize that when we were younger, did we? The beauty of the factoring tree is it allows you to factor a number in a way that you already know. I memorized in school class that 36 is 6 times 6, or 4 times 9, or 3 times 12, and any of those ways would work. I think 6 times 6 is the most intuitive, as long as you continue to break down numbers smaller. Because 6 could break down, class, into 3 times 2, and this 6 could also break into 3 times 2. And notice the prime factors are still 2 2s and 2 3s. What if somebody else said, well, when I see 36, I don't immediately think 6 times 6, I think 3 times 12. Okay, can the 3 break down smaller, class?
No.
No. But the 12 can. What's the 12?
6 times 4.
Either 3 times 4 or 6 times 2. The first thing I heard was 6 times 2. Can the 2 break down smaller?
No.
But the 6 can. What does the 6 break down to?
3 and 2.
3 times 2. Now watch. I've got this 3. I'll just bring it down. I've got this 2. I'll bring it down. Notice I've still got 2 times 2 times 3 times 3. Same 4 factors. Maybe somebody else says, well, when I see 36, I see 4 times 9. Great. What's 4 split into, class? 2 times 2. What's 9 split into?
3 times 3.
Do you still see you're still getting the same prime factors, but it gives you the freedom to kind of split it however you see it. And especially with bigger numbers, this is going to be helpful. Consider this. Maybe a blank sheet of paper, maybe the backside of your homework that you used. Get some paper out, and let's do a few factoring trees together here. The key is, once you get a number that's prime, you can't split it up anymore. But until you hit a prime number, keep splitting. So let's take the number 42. The most natural way, based on what you memorized in elementary school class, is 6 times 7. Could you do 2 times 21? You could. Could you do 3 times 14? Nerd. But you could, okay? 6 times 7 is what we memorized in school. Let's make it easy. Let's split the 6, class.
3 and 2.
3 times 2. Can I split the 7?
No.
So just bring it down and look at my factors of 42. If we put them in numerical order, 2 times 3 times 7. Now again, you have to think through putting them in numerical order with this method, but that's not a big deal. Write this one down. 19. What is the most natural way to split up a 90? Page?
10 and 9.
10 times 9. That's what we memorized in school, so let's split it that way. Again, 2 and 45 could work, but why? 9 and 10, we memorized that. Let's split the 10 again, class.
5 and 2.
5 and 2. Let's split the 9, class.
3 and 3.
I'm getting a lot of help from Paige here. Any of the rest of you jumping in here? How would I list the factors of 90 then, Bryson?
2 times 3 times 3 times 5.
Excellent. There we go. All right, write this next one down. 72. There's 2 different ways you memorize it. I don't care which one you go with, but I'm going to give the option to Michael. How do you want to split the 72? 6 times 12. Now, if 8 times 9 came to your mind first, do it that way. In his mind, 6 times 12 came first. Great. Either one's fine. There's other ways you still could have used. I like those 2. Let's split the 6 again, Michael.
3 times 2.
And let's split the 12.
6 times 2.
And we're not quite done, though. One of these needs to split again.
6.
Into
3 times
And we need to bring down all the other factors that didn't split again. So how would I write my prime factorization of 72, Kirsten?
3,
Well, put the smaller numbers first.
2 times 2 times 2
And by the way, you could cross them out as you call them too. So 2 times 2 times 2.
times 3 times 3.
There we go. And there's our prime factorization. How many say, you know, now that I see this, I kind of like the factoring tree better than the division of primes. It's up to you. Whichever one you prefer. The point is you have options, right? Whichever one you want. Let's do one more. 120. The bigger the number, the more valuable the factoring tree. What's the most natural way to split a 120? Ben?
10 times 12.
10 times 12. There we go. And then we need to split the 10, Ben.
2 times 5.
And split the 12.
2 times 6.
And I can't split the 2 or the 5 or the 2, but I can split the 6. We've got to keep going. Split the 6.
2 times 3.
2 times 3. Now, watch. You know mathematicians are
Lazy.
all right? I am too lazy sometimes to bring down the numbers that don't split. So watch what I might do. I might just circle like that. There's my prime factors. Now I do need to list them numerically. Okay, so what would be my numerical listing here? Let's see, Sam?
2 times 2 times 3 times 5.
There we go. 2 times 2 times 3 times 5. Now, I'm going to let you pick the way you want to do these. Turn the page 16. We did not do 27 through 30 yet, and I saved them on purpose. You may want to do them on paper as opposed to in your book, but you can either use division of primes. If you liked that yesterday, and you say, yeah, I'm not into the tree thing, fine, do a division of primes, that's great. If you're like, I really like this tree, I'm going to give that a try. Do a factoring tree, but do page 16, numbers 27 through 30, prime factor by whichever method you personally like best. I will leave the choice to you. Page 16, 27 to 30. Question or finished? Several people already finished. Absolutely not. One thing here I'm noticing. Remember when you're factoring, don't stop the factoring until you've got only prime numbers. If you have anything that's composite, you're not done. Do it by the factoring tree method. Memorize in elementary school how to something times something equals 81. Start by splitting it into that something times something. What's your question? Question. You were never told that you wanted. Let's put it that way. About a minute and a half or so to finish up, and then we'll go over these together. Ben, good posture. Nice and straight. There you go. Good posture. Help me think. All right. Looks like most of us are about done. Let's start with the 80, and I'm going to go to Griffin first. Griffin, did you use division of primes or the factoring tree?
Division.
Division of primes. What did you divide 80 by?
2.
2. It's easy to cut that in half to get
40.
40, and then it should be easy to cut that in half again, right? Divide by 2 to get
20.
20. Cut that in half by 2 to get
10.
10, and then divide that by 2 to get
5.
5. So your prime factorization was?
2 times 2 times 2 times 2 times 5.
There we go. By the way, Michael asked, hey, can we use the raised dot? Yes, I taught you raised dot. If you're like, I don't want to put all these little x's in between, that takes so long. That's why mathematicians came up with the raised dot. So yeah, absolutely, if you want to use the dot, you can. If you like the x, you're like, no, since my youth have I used the x to show multiplication. Verily, ask me not to get rid of it, Mr. Nadasky. Okay, you can use it a little bit longer, kid. All right, but 2 times 2 times 2 times 2 times 5. How many had that for your prime factorization of 80? All right, questions on that one? How about 225? Paige? What's the first, did you do tree or division of primes?
Division.
Division of primes. As we look at our list of prime numbers, can we use a 2? No. Can we use a 3? Technically, we can. What's 2 plus 2 plus 5, class?
9.
9. Does 3 go into 9?
Yeah.
We could have used a 3, but I mean, it's screaming at you. Which prime number is screaming at you, class?
5.
The 5. So if you used the 5, I got no issue with that. And probably if you did the tree, you still used the 5 anyway. What did you get when you divided the 225 by the 5?
45.
45. And then what did you divide by?
5.
5 again. It's just, it works really well, leaves you with a
9.
9. Then that needs to be split up with the
3.
3, and then finally end with a.
3.
When we list our prime factors, though, we'll write
3 times 3 times 5 times 5.
how many had those prime factors for 225? Questions on that? All right, how about 32? And let's go to Jalen. Did you do tree or division of primes?
I used tree.
You used the tree. All right, how did you split up 32?
8 times 4.
8 times 4 is the most natural. That's what we learned in elementary school. But we keep going, right? We have to split the 8 up.
2 times 4.
And we have to split this 4 up.
2 times 2.
And we still have to split this 4 up.
2 times 2.
2 times 2. Oh, so when we go to check, again, we could bring these down, or I could just make a really funny looking circle. I'm not quite sure what that looks like. Maybe a sea monster?
It's kind of like a worm.
Maybe a badly deformed horseshoe, or a worm, whatever. Anyway, what are our prime factors of 32, Jalen?
2 times 2 times 2 times 2 times 2.
You have 5 of them in there, right? And how many had all 5 of those 2s as your factors? All right, 81, and let's go to Benjamin. Did you use the tree or did you use division of products? Tree here is a huge lifesaver because there's a natural way to split up 81.
9 and 9.
9 times 9, right? We learned that in school, and both 9s have to split.
3 times 3 times 3.
And there we go. So our 81 becomes,
3 times 3 times 3 times 3.
there we go. And man, that's a lot of writing, isn't it? Now, if you look right across the page, if you look down at the bottom of the page, you see a term I think you're familiar with from 6th grade, and that's the term exponents. How many remember learning about exponents? Now, the exponent, and Ben's over here like, no, Ben, this is your friend. Mathematicians are lazy. So, Benjamin, I don't want to write 2 times 2 times 2 times 2 times 2. How many 2s are there, class? 5 of them. And mathematicians be like, I cannot be wasting my whole life writing a whole bunch of 2s. No, sir. Not going to do it. I'm going to write 1 2, and I'm going to put a little 5 up here to show that I got 5 of them. And that's what it means. Instead of writing 5 blasted 2s, you write 1 2, put a little 5 up there, and you move on with life and go watch football. It's a great life with exponents, right? Don't waste your life writing numbers. Watch football. Starting next weekend. Yes. All right, anyway. So for 81 class, no. I ain't got time to be writing 3 times 3 times 3 times 3. No, we're going to write, class, a little, one single 3, and above it, we're going to put one little exponent called a 4. A little 4. Just put that little exponent up there. Boom. So much quicker and easier. Even something like this. Now this, admittedly, we're not going to save a ton of time, but instead of writing 3 times 3, I could write a 3 with an exponent class of 2, because I have 2 3s. I also have 2 5s, so I could write a 5 with an exponent of 2 as well. These are the same thing. Now, you say, does that actually save me much time? I wrote 1 2 3 4 numbers, I wrote 1 2 3 4 numbers still, right? Well, 2 fewer raised dots? I am that lazy. Looking here, how might I rewrite this expression? Instead of writing what I wrote, Corey.
2 with an exponent of 4 times 5.
There we go. And this is another way to write it out. Now, some terminology that we need to talk about. Obviously, we understand that the little raised number is called the exponent. But we actually have a name for the 2 as well in this case. The number that is raised to an exponent or to a power, is the other way to call it, is called the base. The base. Think of it this way. How many have seen, maybe in a football game, basketball game, seen cheerleaders? You ever seen them do where they stack the girls on top of each other and stuff, and the one's up at the top? And the person at the bottom is called the base. The base of the mount. Well, think of it this way. Here's the flyer. She's the cheerleader at the top, and this is the base, the cheerleader at the bottom. Base, exponent. So here, class, we have a base of 3 and an exponent of 2. Class, here the 5 is our base and the exponent is 2. Now listen to this. When we read exponents, though, you're going to encounter a 2 exponent a lot. A lot. And so mathematicians came up with a special name for an exponent of 2. They call it squared. Squared. So here, instead of saying 3 with an exponent of 2, it's faster and lazier to say 3 squared. So right here, class, this would be
5 squared.
5 squared. Now, they don't have a cool name for 5, but here's what we're going to say instead of 2 with an exponent of 5. That's a whole lot of syllables to get out, right? To the 5th power. To the 5th power. So this is 2 to the 5th power. Can I say that with me? 2 to the 5th power. How do you suppose we would read this one then, Luciana?
3 to the 4th power.
3 to the 4th power. Very good. Look over at page 19 now. Flip over to page 19. They've given you 4 different expressions on numbers 1 through 4. They've got 39 to the 12th power, 9 to the 35th power, 5 to the 15th power, and 4 to the 6th power. They want you to write the base in each case and the exponent in each case. Take about 10 seconds to write in what the bases and exponents are. Do 1 through 4. And Bryson and Jalen are all ready. Okay, do numbers 1 through 4 in your book quickly. Right. Oh, you just dismembered your pen. Hard to write with a dismembered pen. Class, for number 1, the base is?
39.
The exponent is?
12.
For number 2, the base is?
9.
The exponent is?
35.
For number 3, 5 is the base and 15 is the?
Exponent.
For number 4, 6 is the?
Exponent.
And 4 is the? Base. There we go. All right, I want you to rewrite 5 through 10 with exponents. Just rewrite them so that they have exponents instead of all that nonsense. Write them out with exponents, 5 through 10. Bottom of the page. Page 19. So remember, excuse me, there should be no humming, singing, or other wailing noises. All right, so you're going to write these ones with the exponent, and then just tack that on at the end and say times 3. You write that with an exponent times those with the exponent. So, number 5, what did you write for your answer? Kirsten?
5.
To the third power?
Third power.
There actually is a shortcut name for the third power as well. So what was the shortcut name if it's a 2, class?
Square.
Squared. What was it with a 2?
Square.
Squared. With a 3, we say cubed. What do we say for 3, class? Cubed. All right? So here we could say 5 to the third power, and that's not wrong, but it'd be faster, class, to say 5 cubed. There we go. How about number 6? What would we have for this one? Elaine?
13 squared.
13 squared. How about number 7? Jalen?
9 to the 4th power.
9 to the 4th power. How about number 8, Michael? 2 to the 4th power. All right, number 9. How will we write this one? Paige?
2 to the 3rd times 3.
2 to the 3rd power times 3. Or we could say, class, 2 cubed times 3. Very good. How about number 10? Let's see if we can say it perfectly. Ben wants this one.
3 squared and 5 cubed.
There we go. 3 squared times 5 cubed. Great job. How many have the same thing? They're on number 10. Questions on that? All right. Flip over real quick. We're not going to do all of these necessarily, but let's just do 14 through 16 on page 20. Page 20, 14 through 16. They've written these with exponents. So look at number 14. It says, class, 4 cubed. 4 cubed. Now, first of all, they want you to write it out. What does 4 cubed actually mean, class? 4 times 4 times 4. And then they want you to figure out what that is. What is 4 times 4 times 4? Sam? Not 18.
84.
Ooh, not 84. 64. 4 times 4 is 16, times another 4 will give you a 64. You do that for 15 and 16. You figure out 15 and 16 at your seats. And we'll call that good for today. We'll practice with more of this next week. All right, so first of all, how would we read number 15, class?
3 squared.
3 squared. What does it literally mean, Paige?
3 times 3.
3 times 3, and of course, class, that equals
9.
9. Stay with me. For the next one, it says what, Bryson?
10 cubed.
Which literally means what, Griffin?
10 times 10 times 10.
Which equals, class?
1,000.
1,000. 1,000. All right. Homework for the weekend is to do pages 20 to 21. Pages 20 to 21 in the homework section. Page 20 to 21. Do the homework section 1 to 20. Pages 20 to 21, the homework section, numbers 1 through 20. So for the second straight night, you're just finishing a complete homework section. Should be really easy to remember for a change. Pages 20 to 21, numbers 1 through 20 in the homework section. All right, you are dismissed. Have a wonderful rest of your day.